In this video, we're going to discuss the other trigonometric functions and their graphs. This is a pretty long video, so I'm going to only do or introduce the other trigonometric functions and talk about the graphs of one of the additional trig functions. And so the same setup that we use for evaluating trig functions for the sine and cosine functions, we'll use those same methods for the other 4 trig functions, making a total of 6 trig functions. And so what we did was we let alpha be an angle in standard position and xy be the point of intersection of the terminal side of alpha and the unit circle. And so if I drew my angle in my xy plane, I have my unit circle here. This is x, this is y, of course, my x and y axes. This is my initial side. My terminal side, let's say, lies in my second quadrant. The point of intersection, we're calling the ordered pair x, y. And so we said that the sine was the y coordinate of that point of this unit circle, where that terminal side intersects the unit circle, and the cosine was the x coordinate. The other trig functions are based off of ratios of these coordinates here. For instance, if I did the ratio of y divided by x, that is how we define our tangent function. And then cosecant is the same thing as 1 over the y coordinate. Secant, S-E-C, secant. By the way, let's do these words. This is cosecant of that angle alpha. This is secant. We use SCC. That's 1 over x. And then we have cotangent. This is actually tangent. All right. So this is cotangent, and we have x over y. All right. And so what we have here is we've defined 4 additional trig functions. And if you notice, they are both based off of, or all 4 of them are based off of y coordinates and x coordinates of this point here, where our terminal side of our angle intersects the unit circle. Because sine of alpha equals y and cosine of alpha equals x, we can write these other trig functions, the tangent, the cosecant, the secant, and the cotangent. We can write them as functions of sine and cosine. I'm actually going to pull this up a little so that we can see what I'm about to say a little more clearly. So now that we have all of that information, what we can do is we can see that, oh, tangent is y over x, and so if sine of alpha is y and cosine of alpha is x, then tangent is the same thing as sine of alpha divided by cosine of alpha. So tangent is exactly equal to that. Cosecant is 1 over y, and since sine of alpha equals y, we can write cosecant as 1 over the sine of y. Sorry, not y, the sine of alpha. 1 over the sine of that angle, whose sine value is y. All right. Secant is 1 over x, and so since x is the same thing as cosine of alpha, secant of alpha is the same thing as 1 over the cosine of alpha. And since these two are reciprocals of each other, well, we're not going to talk about the reciprocal property now. We'll save that for later. We're trying to write these in terms of sine and cosine. And since this is x over y and cosine is x, I can write this as cosine of alpha. And then this denominator is y. And we said here that y is defined as sine of alpha. So it's cosine over sine. And so we can write all of our other trig functions in terms of just sine and cosine, given these definitions here. Okay? And so what we're going to want to be able to do is we want to be able to evaluate these trig functions. I know that we've already talked about, we already talked about that, but we already talked about how we can, which quadrants our sine and cosine functions are positive and negative in. What we want to do is we want to add these other trig functions, right? And so since these trig functions are based off of the x and y coordinates to these ordered pairs, and both ordered pairs are positive in the first quadrant, then they're all going to be positive in the first quadrant. So every single trig function evaluated at an angle that has its terminal side within the first quadrant is going to be positive. In the second quadrant, notice these x values are negative. All right, so anything that uses an x value is negative. So we know that cosine is negative, and it, or the 1 over x, which was the secant, is going to be negative. However, positive is the y-coordinate. So we already said it was sine. So sine of alpha, or the sine function, is positive. And the cosecant function is as well, since that is 1 over y. Now, since tangent and cotangent are a division of your x and y coordinates, when you divide a positive and a negative value, you're going to end up with a negative value, right? So sine and cosecant are the only two trig functions that are positive in the second quadrant. In the third quadrant, since the x coordinate and the y coordinates are negative, and if you divide a negative by a negative, that means anything that uses both coordinates would be positive. So in the third quadrant, both tangent and cotangent are positive. And in the fourth quadrant, cosine, which is the x coordinate, and secant, not cosecant, are positive, right? Knowing which quadrant they're positive in will allow us when we're evaluating the trig functions, and we're going to see that in a couple of seconds, right? One way to remember this is to use this acronym here. A is for all, sine, it starts with an S, so we're going to say students. Tangent starts with a T, so we're going to say take. And cosine starts with a C, and so we're going to say calculus. All, students for sine, take for tangent, calculus for cosine. Now, what you have to remember is the other trig function that is the reciprocal of the trig function that's positive that created that acronym, that's also going to be positive. So what we can see is that sine and cosecant are reciprocals, right? That's y over 1, and this is 1 over y. Cosine and secant are reciprocals. That's x over 1. The reciprocal will be 1 over x. And tangent and cotangent are reciprocals. That's y over x, so its reciprocal is x over y, right? So since they use the same basic variable makeup in their expressions or their ratios, then they're going to have the same signs in the same quadrants. All right, so all students take calculus, all are positive in first quadrant, sine in the second quadrant, tangent and its reciprocal in the third quadrant, and cosine is in its reciprocal in the fourth quadrant. Evaluating these trig functions are a bit much more harder or more difficult to handle. So let's look at evaluating some of these. We're going to start with the tangent of pi over 6. Now, I've memorized the first quadrant of my unit circle, and I know these rules or properties or relationships between numerator and denominator when my angles are written in radians, right? Pi over 6 is in the first quadrant. That's equivalent to that 30-degree angle. We're going to remember that tangent is y over x. The y coordinate to the terminal side, where the terminal side intersects the unit circle for that angle, is 1/2. The x coordinate is square root of 3 over 2. I definitely want to simplify that, right? Well, when you divide by a fraction, you multiply by its reciprocal. The 2's cancel, and so we get 1 over the square root of 3. We would like to rationalize our denominator by multiplying the numerator and the denominator by the square root of 3 over the square root of 3. And then we get square root of 3 over 3 as our solution. Cotangent of 120 degrees. This cotangent is x over y. That's the ratio I'm going to have to remember. But this angle is in the second quadrant. Its reference angle is how much it needs to get to 180, which is 60 degrees. And so cotangent in the second quadrant is negative. It has a reference angle of 60 degrees. And I know the 60-degree angle in the corresponding ordered pair in my first quadrant of my unit circle. The x coordinate of that point is 1/2. The y coordinate is square root of 3 over 2. Which is basically the same setup I had over here. So this is going to end up simplifying to negative square root of 3 over 3. The secant of negative 90 degrees, right? Well, 90 degrees is the positive portion of the x-axis when we're going in the positive direction for angles. So this is going to be the negative portion of the y-axis. And I meant the y-axis the first time. It's going to be the negative portion of the y-axis. Well, that has an ordered pair, right? Remember? That'd be the point on my unit circle, 0, -1. And so since this is the secant function, and that represents 1 over x, then the secant of -90 degrees is 1 over that x coordinate, which is 0. And we know that when we divide by 0, we are undefined. All right? And so it just so happens that this one is undefined. Let's go to secant of negative pi over 3. That's 1 over y. That's secant. Negative pi over 3 would be in my fourth quadrant. A coterminal angle for this would be 5 pi over 3. 5 pi over 3 has a reference angle of pi over 3 since it's in the fourth quadrant. We know that sine and cosecant are going to be negative because cosine and secant are the only positive ones. So this is equivalent to finding the cosecant of pi over 3. Well, the y coordinate at pi over 3 is square root of 3 over 2. That means to do the reciprocal, when I divide by a fraction, you multiply by its reciprocal. So we have a -1 times 2 over the square root of 3. I don't have to write that negative. I multiply by the square root of 3 over itself, and I get -2 square root of 3 over 3. And so that is an evaluation of that cosecant function. All right. And so with that being said, we should be able to evaluate the other 6 trig functions. And what we're going to do now is we're going to move towards graphing our tangent function. Now, when we started, you don't have this in your notes, but when we started looking at graphing, we looked at trying to, pick some angles that's full on around our unit circle, 360 degrees or 2 pi radians, right? And so we basically picked our quadrantal angles, which are these angles here. 0 and 2 pi are the same angle, which is why we have 5, but it looks like we have 4. And we plug those values into our function and we get our output. Remember, your tangent is your y over your x to that point on your unit circle where your terminal side intersects it, right? So at the point when the angle is 0 radians, my y coordinate is 0, my x coordinate is 1, and so we get 0 as our tangent. When I go to pi over 2, my y coordinate is 1, my x coordinate is 0, so we get undefined. At pi, we get 0 over -1, which is 0. At 3 pi over 2, we get -1 over 0, which is undefined. And then at 2 pi, we get 0 over 1, y over x, which is 0. Now, what we have here is some undefined stuff, right? So if I were to try to graph this 0, pi over 2, pi, 3 pi over 2, 2 pi, when we end up dividing by 0, we end up having a vertical asymptote, all right? It's going to be a vertical asymptote. Those values are not in my domain and nothing cancels, so we have a vertical asymptote. The same stuff happened when we dealt with irrational functions. And then at 0, I get the point 0, 0. At the point pi, I get the point pi 0, and then I get 2 pi 0. Well, what we don't know is how our graph approaches these asymptotes here, right? Am I going to go up here, down here, wherever, right? So what we're going to have to do is we're going to have to rearrange or pick up some new values instead of using the same values that we use for the sine and cosine function. And I've already done that for you. I found some points that are very good points to find. We're going to use these x values. We're going to plug them into our trig function, and we're going to get the output value, right? Our tangent function. Now, at 0, I know I had 0. At pi, I had 0. So we already know 0, 0. Pi over 2, we had undefined. So those are already figured out. So let's plug in negative pi over 2. Well, negative pi over 2 is this point right here on our unit circle where we had 3 pi over 2 if we were going in the positive direction. And notice if that was a tangent, that would be a -1 over 0, which is also undefined. All right, plug in pi over 4. Pi over 4 is the same point where we had 7 pi over 4. That's tangent is negative in the fourth quadrant. So this is going to be the same thing as negative tangent of pi over 4. And at pi over 4, we have a y coordinate of square root of 2 over 2 and an x coordinate of square root of 2 over 2. So when we divide those two together, we're going to get a 1. So we get a -1 there. And then pi over 4, the tangent of pi over 4 is 1. And so what's happening here is that we're going to have a vertical asymptote at x equals negative pi over 2. We have another one at x equals positive pi over 2. At negative pi over 4, our y coordinate is negative 1. We get 0, 0, and pi over 4, 1. Okay? And so we're going to get a function. All right, that's a bad function. All right. It's going to have a little curvature like that. It's harder for me to draw on this here. All right, but there's a representation of my function. Now, if I were to continue to go on, this pattern would repeat itself. And so I get a negative 1 here, 0, 1. I'm going to have another vertical asymptote at x equals 3 pi over 2. And so I'm going to get a function that looks a little better. And then I considered the same pattern here. Uh-oh. I messed up there because I didn't go through x equals 1. I went through x equals negative 1. That's why it probably looked better, because I'm counting by a half there. And so I need to go here. So that's x equals 3 pi over 2. And then my patterns would continue to the left here. And so at negative 3 pi over 2. So on and so forth, right? But this is what we're going to have here. And we're going to have an infinite number of vertical asymptotes. And this is going to be our function here. Let's start with figuring out what our range is, right? So since my function is continuing and approach this vertical asymptote going down continuously, and then this one going up continuously, our range is negative infinity to infinity. Our domain, we have to skip over pi over 2, we have to skip over 3 pi over 2, negative pi over 2, negative 3 pi over 2. The next one we will skip over is negative 5 pi over 2. Over here, it'll be a positive 5 pi over 2. So we're basically skipping over odd multiples of pi over 2. And so what I'm gonna write my domain as all real numbers except, so this backslash here means except. There's multiple ways we can write this. I'm gonna write it this way. I'm gonna say pi over 2 plus pi times k, where k is a member of the set of integers. That's a double barred z, okay? A double barred z, and that means k is an integer. So if k equals 1, that's pi over 2 plus pi, which is that 3 pi over 2. If k equals 2, or negative 1, that'd be pi over 2 minus pi, which is that negative pi over 2. If k was 2, that'd be 3 pi over 2. If it was, sorry, that would be 2 pi, which is 4 pi over 2 plus pi over 2, which is 5 pi over 2. And then we get the 7 pi over 2, 8 pi over 2, so on and so forth in both the positive and negative direction. All right, so it's all real numbers except pi over 2 plus pi k, where k is an element or basically an integer. Our fundamental cycle actually runs from negative pi over 2, that's the one that I have in red up there, to pi over 2. And this is a periodic function, so it repeated itself. And so the period is actually the length of our fundamental cycle. And since it runs from pi over 2 to negative pi over 2, negative pi over 2 to pi over 2, if I think about the distance here, if I subtract these two here, I'm going to get pi units. And so my fundamental cycle runs from negative pi over 2 to pi over 2. My period is the length of that cycle, which is pi units. Just as we've talked about or discussed graphing the general sine waves, we can graph the general tangent graph. A represents a vertical stretch. It can also represent a reflection about the x-axis. B affects the period because it's a horizontal stretch. This C is a phase shift or a horizontal shift, and it affects the fundamental cycle. And that D represents a vertical shift, up or down, right? And so, unlike the tangent, the sine and the cosine functions that had a fundamental cycle that started at 0 and went to 2 pi, our tangent function has a fundamental cycle that ranges from negative pi over 2 to pi over 2, not including those since those values are not in the domain. And so what we're going to do to see what happens to the fundamental cycle or interval when we have a general tangent function is we're going to replace this x with b times the quantity x minus c. Divide both sides by b. Now, if I divide both sides by b, that's the same thing as multiplying by 1 over b. And when I multiply a fraction by 1 over b, that means the denominator gets multiplied by b. So I get negative pi over 2b is less than x minus c is less than positive pi over 2b. Then I can add c to both sides. So I have a c minus pi over 2b. You can write negative pi over 2b plus c, but I want my c first. And then I have c plus pi over 2b. So my fundamental cycle is actually going to range from from c minus pi over 2b to c plus pi over 2b. And that means my period is going to be basically the distance of this, or the width of this cycle here, right? So all I have to do is take this number, which is c plus pi over 2b, and subtract from it this number here. So my period is going to equal, well, I c minus this c is that. I have to distribute this negative, so that's pi over 2b plus pi over 2b, which is 2 pi over 2b. So my period, the 2's cancel, is pi over b. So my period is pi over b. My fundamental cycle is from c minus pi over 2b to c plus pi over 2b. And so what we're going to do is we're going to look at this example here, and we're going to graph this trig function. What I'm going to do is, I know it says to find the period, but I'm going to find the period, the fundamental cycle, the phase shift, all that stuff, right? I have to rewrite it in the form b times x minus c. When I factor out this 2 from both of these terms, I divide both of these terms by 2. 2x divided by 2 is x. Pi over 4 divided by 2 is the same thing as multiplying by 1/2. Pi over 4 times 1 over 2 is pi over 8. Okay, so the A is -3. That's a vertical stretch and a reflection. My B is 2. That represents my, this affects my period. And C equals pi over 8. That is my phase shift. All right. And so if I wanted to write out my period, it would be 2 pi. No, it would not be 2 pi. My period is pi over b now, which is pi over 2. My C is my phase shift, and my phase shift is consumed in my fundamental cycle. So let's go to my fundamental cycle. I'm going to abbreviate that with FC. All right, that's C minus pi over 2b to C plus pi over 2b. It is an interval. And so my C in this example is pi over 8. And so I'm going to fill in this formula here, and then we'll simplify. Well, 2 times 2 is 4, right? And so that's pi over 8 minus pi over 4. Pi over 4 is -2, or is 2 pi over 8. So that'll be a negative pi over 8. And that's pi over 8 plus 2 pi over 8, and that'll be 3 pi over 8. So my fundamental cycle has allowed me to now use the same method that I used before with the sine and cosine functions. What I can do is divide my fundamental cycle into 4 equal subintervals. We know that the full length of the subintervals is the same value as our period. And to get the width of each of those subintervals, we divide our period by 4, taking a fourth of it. That means multiplying the denominator by 4, we get pi over 8. So the distance from here to here is pi over 8 units. From here to here, pi over 8. From here to here is pi over 8. And from here to here is pi over 8. And so all we have to do is start with our leftmost endpoint and add pi over 8. Add pi over 8 to that, I get 0. Add pi over 8 to that, I get pi over 8. Add pi over 8 to that, I get 2 pi over 8, which is pi over 4. And 2 pi over 8 plus pi over 8 is 3 pi over 8, which we have here. So we know we've done that right. Now, if we go back to our tangent function, so we're going to get an undefined statement at first point is going to have a y value that's undefined. Then my second point has a y value that's -1, 0, and 1, and then we get to undefined, right? So the same thing is going to happen with these points. It's going to be undefined. I'm going to abbreviate that with UD. Then it's going to be -1, 0, and 1, right? So this is my original. Well, I'm graphing, and this is if I want to use these transformations here, I'm graphing -3 times that. So I'm going to reflect about the y-axis, and I'm going to multiply by 3. Will that reflection reflect about the x-axis? Not y-axis. The x-axis, right? Well, something that's undefined is going to have a vertical asymptote. It's going to stay undefined. I can't reflect it. But I multiply all of my y values to these points by negative, and I get something that looks like that, right? Then I can do my vertical stretch, because that's a multiplication by 3. By a factor of 3, vertical asymptote is going to stay the same, right? But I multiply these by 3, and I'm going to get 3, 0, and -3. And so if I wanted to sketch the graph of 2 cycles, for instance, I can draw me an XY plane. And what I'm going to do is I'm going to count by pi over 8. So we have a negative pi over 8, 0, pi over 8, 2 pi over 8, or pi over 4, 3 pi over 8, 4 pi over 8 is pi over 2, 5 pi over 8, 6 pi over 8 is 3 pi over 4, 6 pi over 8, 7 pi over 8. And I think that'll be enough for me to get me 2 cycles. I'm going to go y equals 1, 2, 3, -1, -2, -3. And I'm going to start by graphing my vertical asymptotes. X equals pi over 8, and I'm going to notate that on my graph, negative pi over 8. And x equals 3 pi over 8. I know at 0, I'm going to have a y value of 3. Pi over 8, I'm going to have a y value of 0, -3. And so it's going to be a graph. Uh-oh. All right. That looks something like that. And let me make that bigger so you can see that it goes through pi over 8. And then I can do another cycle by repeating that process. So at pi over 2, I'm going to have a y value of 3. I'm going to have a y value 0. I'm going to have a y value -3 at 3 pi over 4. And I'm going to have another vertical asymptote here. And I have another cycle, okay? And so that is the graph of this trig function here. Now, if you didn't want to use those reflections and that vertical stretch, remember you could also, and this may be an easier option, it may, I say it may be an easier option, sometimes it can be a little confusing, but you have y equals -3 cotangent, and you can go back to your regular function written this way, or you can go to the function here, and I don't know why I wrote cotangent, it's the tangent of 2x minus pi over 4. You can plug in those values, plug it into your function, you get -3. Now, if I plug in negative pi over 8 here, I get negative pi over 8 times 2, which is a negative pi over 4, and a minus pi over 4, which is negative pi over 2. So this reduces to -3 tangent of negative pi over 2, right? Which we found to be one of our base functions. Our function would be undefined, right? Because at pi over 2, negative pi over 2, our y coordinate is -1, our x coordinate is 0, so we'd be divided by 0, right? Let's do one more. We'll see that so that we can see that we actually get the 3. Let's plug in 0 for x. This is going to be tangent of 0 minus power 4, which is negative power 4. The tangent of negative power 4 is -1, and a -1 times a -3 is a +3. All right. This one's going to be 0, this one's going to be -3, and this one's going to be undefined. And so if you don't want to rely on using your vertical stretches or your stretches and compressions and your reflections vertically, then you can create a table of values and you'll get the same values from that process. All right, we're actually going to stop here. I know that there's more to this section, but I don't want to get this too much longer. And so we're going to stop here and we'll see you in the next video.